All right, so the first thing we're gonna do is find the possible roots, right? So we're doing, first of all, check to make sure it's in order from highest exponent down to none. I don't have to fill in the spaces yet, because when I'm trying to figure out first and last, but I do have to figure out that it's in, which it already is, right? The last, so it's plus and minus last over first. Last is 12, which is gonna be 1 and 12, 2 and 6, 3 and 4. So far, all we've had is a 1 at the front, but I wanna make sure that we're clear that, like, if that 1 was a 6, let's say, then I'd have 1 and 6 and 2 and 3, and I'd have to put all the numbers at the end over 1, then all the numbers at the end over 2, then all the numbers at the end over 3, then all the numbers at the end over 6, and then simplify it out, okay? So this still has a leading coefficient of 1, so my possibles are just plus and minus 1, 2, 3, 4, 6, and 12 over 1, which would be negative 1, positive 1, negative 2, positive 2, negative 3, positive 3, negative 4, positive 4, negative 6, positive 6, negative 12, positive 12, okay? If this was an open-ended question, you're like writing it on a piece of paper or something like that, you're submitting a picture of it, and you put plus and minus 1, 2, 3, 4, 6, and 12, that's totally fine, okay? But if it wants it to auto-check it, it's going to be negative 1, positive 1. You have to write them all out, okay? Then I'm going to figure out which one works by using synthetic division. So I'm going to make sure now that my exponents are highest to lowest and there's no terms missing, which there's not. 1, 3, negative 4, negative 12 would be my coefficients and my constants. And then let's start with negative 1. So I put negative 1 on the outside. Bring down this. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, not going to be 0. Remember those tools that I taught you last week that said Descartes' rule and upper and lower bounds, right? If you just glance at this, there is one sign change, right, from my beginning. It goes from positive to negative, which means for sure I'm going to have a positive root. Remember, if it was 2, then it's 2 or it's 0, right? But the fact that there's going to be one positive root means that maybe I don't even test any of the negatives yet. One of these positive ones has to work. Does that make sense? So it's a tool to help you narrow it down. So if that's the case, I'm going to put 1 on the outside. Let's try it. 1, 3, negative 4, negative 12. Bring down the 1. That's not it. So negative 1's not it. Positive 1's not it. Instead of going to negative 2, I'm going to go to positive 2. And there's the first one that works. So positive 2 is a root. And then I'm going to take my decreased degree polynomial and factor it further, x plus 2 and x plus 3. Set them each equal to 0, and I get x equals negative 2 and x equals negative 3. And just like we used Descartes' rule to tell us there's only one positive root, the other 2 were negative. So you have to do a little bit more work to figure out Descartes' rule on the negatives. You have to plug in that negative x and then simplify it. But it is also something that can help you. If I had done that, you should have gotten 2 or none, right? So I probably would have just stuck with plugging in the positives, but at least you would have seen from your answer 2 negatives make sense with the Descartes rule. So A is all your possibles, which was all this stuff here, and B is the actual roots. So I don't think I'm going to try to slam in a quiz this week. I really wanted to because of some of your grades on quizzes aren't great, and I wanted to be able to pull it up. But because we have a half day today, a half day tomorrow, regular Wednesday, Thursday, but then we're back to half day on Friday, I just don't want to slam it in. So what I'm going to do is I'm going to give you the quiz review as if you were taking the quiz. I'm even going to share with you a paper, like a PDF copy of what the quiz would have looked like, so you know what you would have been assessed on, so that it's not test times the first time you're looking at something like that. But I just don't want to slam you. I think this week's going to be nuts. So I'm going to try not to do it. But just a heads up, like should you see something like this on the test, you would get a function that you're going to have to find one root from. So you're going to list all your possibles. You're going to find one root, and I will most likely give you something that you'll use your graphing calculator to find that one root. Then you will use synthetic division to bring that down a degree, and it won't be factorable from the beginning, so it's forcing you into that. And then your remaining roots you'll get from what we're about to do today, either quadratic formula or even root property, that kind of stuff. Okay, I don't know if we're going to get quadratic today or tomorrow, but you can use that. Okay, so just keep that in mind. You're still going to have to find your possibles. You're still going to have to use synthetic to reduce it a degree. But then what you get from there, you'll have to either use quadratic or the even root property. Good morning, Dylan. Dylan, warn your parents I had to mark you late, dude. All right, so we're going to start 2-4, which is complex numbers, okay? Complex means imaginary. Imaginary means the square root of -1. So everything dealing with today is stuff that we've done before, except that now you're involving an imaginary number. Don't ask me why they invented an imaginary number, but they did, okay? So the imaginary number or unit I, and it's usually an italicized I, lowercase I, is the square root of -1. So up to this point, if I had given you something that said like square root -25, you would have told me that there's no real solution there. Now we're saying there's still no real solution, but let's invent this I that allows us to take that negative out, right? The I coming out makes it I times the square root of 25, and the square root of 25 is 5. So this is 5I. You will add, subtract, multiply, divide, and solve functions that have imaginary roots in them, okay? So all that stuff is in this section. When we get into multiplying, you're going to remember that I squared is equal to -1. So if I square I get -1, which means you'll never leave an I squared in an answer. You'll always substitute -1 in its place. There's something called standard form, which is this. Standard form is A plus BI. The A is the real part. So the number without the I will always go first. And then the B is the imaginary part, and that comes second. If there's no if there's no A, it's called a pure imaginary number. If there was no I, it'd be a real number. If there's no A, it's called a pure imaginary number. Good morning, Sebastian. Warn your parents that you were marked absent, okay? So this order, again, is called standard form. It will say simplify or perform the indicated operation and then put your answers in standard form, which means the A comes first. The last thing you should write is that I. All right, just a couple examples of what it looks like with complex numbers. So the complex has, again, the A part and the B part. The A is with the A is the real number. The B is with the imaginary number. So if I had something like this and it said -4 plus 6I, the -4 is the A, the 6 is the B. So the B doesn't have the I on it. The B is just attached to the I. Okay, so if I ask you to identify A and B, A, number without the I, B, number next to the I. And then it says equity of complex numbers. A plus BI equals C plus DI if and only if A equals C and B equals D. So if I was to compare something, 2 plus 3I would have to equal 2 plus 3I because the 2's have to be equal and the 3's have to be equal, okay? So if I don't have an A, in this one I don't have an A, then my A is 0. And in this one I don't have an I, then my B is 0. So I think part of the questions in the homework on website will say like identify the A and identify the B. So you're just plugging those in. All right, express as a multiple of I. So my advice is as soon as you see the negative underneath, take it out. That's the first thing you're going to want to do. So this becomes I times the square root of 16, and the square root of 16 is what? 4. So this is 4I. You don't have to write 0 plus 4I, but if it had asked you to identify the A, it would be 0. 7I squared becomes 7 squared times I squared. 7 squared is 49, and I squared is -1, so this becomes -49. Easy stuff, right? You just got to remember that the I comes out. Adding and subtracting complex numbers, we're going to treat I just like we do a variable, just like it's an X. Okay, and then we're going to combine our like terms, and again, standard form, you always put the I at the end. That's the only difference. So this says perform the indicated operation. Let's call this A and B. Okay, A has a minus between, just make sure you distribute that to both. I'd get 7 plus 4i minus 9 plus 5i. 7 plus, minus 9 becomes negative 2. And then 4i, positive 4i, positive 4i. I changed your color. Positive 4i, positive 5i would be a positive 9i. Standard form says put the real part first, imaginary part second. Okay, B, I don't even have to change any signs. I'm just going to combine my like terms. So 8 plus 17 is 25. And then 3i minus 7i is minus 4i. Super easy, and yet every year somebody forgets to distribute that negative. Don't do that. Don't be that person. Okay. Good so far? Yeah. All right, then we get to multiplication. So we're going to FOIL these out if they're binomials. Every time we see I raised to the second power or higher than that, because that might eventually happen too, we're going to replace it with a negative 1. So your answer should never have I higher than 2, higher than 1 really, in your answer, okay? Again, perform indicated operation. So for A, 3 times 6 is 18. 3 times negative 2i is negative 6i. Negative 5i times 6, negative 30i. Negative 5, negative 2 is positive 10i squared. Combine my like terms, so it's negative 36i. I squared becomes negative 1, and that becomes minus 10. And then 18 minus 10 is 8 minus 36i. If it says put it in standard form, it wants the I always to be at the end. With the exception of like a square root. Like if you have a square root at the end, as long as the I is usually in front of the square root. But the I is always the term that's second. All right, B, 2 minus 3i squared. So this is 2 minus 3i times 2 minus 3i. 2 times 2 is 4. 2 times negative 3 is negative 6i. Negative 3i times 2 is negative 6i. Negative 3i and negative 3i is a positive 9i squared. 4 minus 12i plus 9 times a negative 1, which becomes minus, excuse me, minus 9. And I get negative 5 minus 12i. Still good? Yeah. Good from home? Remember, it's like a speak now or forever hold your peace. All right. First example, is that what you said? Okay, so the conjugate of a complex number, it's called the complex conjugate, okay, is the same exact terms, but one gets a plus and one gets a minus. So the conjugate of A plus BI is A minus BI. The conjugate of A minus BI is A plus BI. When you multiply a complex number by its conjugate, you get a real number because you'll always end up with a positive sign and a negative sign that will cancel out. And you'll always get an I squared, which becomes negative 1, so the I goes away.
Is the B just like supposed to be like a whatever number?
Yeah, so like let's say this is 2 plus 3i. The complex conjugate would be 2 minus 3i. Oh. And vice versa, okay? And when we multiply those out, again, it will always cancel the middle term, right? It's like the difference of two squares. We always, if it's x plus 5 and x minus 5, one of those terms, the middle terms always cancel out, right? The difference between that is if you think about it, if I had x plus 5 and x minus 5, I know the plus 5 and the minus 5 cancel out, but I usually get x squared minus 25, right? Difference of two squares, think about it, right? Now our last term is going to have an I on it, an I squared, which is going to take my negative and switch it to positive. So the shortcut for multiplying complex conjugates, meaning it has an I on it, is a squared plus b squared. So if I was to multiply these two out, it would actually be 2 squared, which is 4, plus 3 squared, which is 9, and I get 13. So complex conjugates, when multiplied together, get rid of the I, okay, and we'll reduce to one number. And the shortcut is a squared plus b squared. So be careful. Don't screw this up. Like a lot of people confuse it with difference of 2 squares. This is plus, because the I squared would change the minus to a plus. Does that make sense? Yeah? Okay. Yeah.
What is a conjugate?
Conjugate is just the same thing with it's the opposite, with the opposite sign in the middle. So if I gave you 7 minus 3i and I asked you for the conjugate, it would be 7 plus 3i. If I had negative 7 minus 3i, it would be negative 7 plus 3i. You only change the sign on the second term. Does that answer your question, Sai?
Yeah.
Okay. And when we multiply these, this is the same thing as saying a squared, which is 49, plus b, remember b, we don't take the I, b squared, which is 9, and that would be 58. So we're obviously going to need these when we get into fractions, because if there's the I on the bottom, we're rationalizing, and we're using these to rationalize. But we'll baby step our way there. All right, example 4 says, write the complex conjugate of the complex number, then multiply the number by its conjugate. So if my original expression is 7 minus 10i, what's my complex conjugate?
Just 7 plus 10i.
Good, 7 plus 10i. And I can either FOIL this out. So when in doubt, FOIL it out, right? When in doubt, go ahead and multiply it out. But I can also use my shortcut, a squared plus b squared. A is the 7, b is the 10, 49 plus 100, 149. I'd get the same exact thing if I FOIL it out. It's just a little bit faster. Questions on that one? Okay, so b is not yet in I form, right? But what is the square root of negative 5? Yep, I root 5. So for me, I tend to put the I on the front when it's a radical. This is the same thing as square root 5i. Just make sure the I is not underneath the root. So that's the mistake people make, is extending out that square root and putting the I underneath that. You can't do that. So both of those are right. I root 5 or root 5i. I think if it's on a standardized test and a multiple choice, the second one is actually how it will be written. Just make sure the root doesn't go over it, okay? So if that's the I part, what would be my A? 0. So like if I really wanted to write it in standard form, I could write it like that if it's easier for you to identify the complex conjugate from that. But if that's my original complex number, what's its conjugate? 0 minus 5i or minus 5i. Okay, so you can write it either way. This could be 0 plus this and 0 minus that. It's the I that's changing the sign, right? That the b is going to be the one that changes the sign.
Root 5 is the same as the root negative 5.
Exactly.
Right?
Yep.
Okay.
So if I multiply these together, I could get I root 5 times negative I root 5. I'd get I times negative I squared. And root 5 times root 5, which is just 5. Negative 1 becomes a positive 1, and this is just 5. If I did it from here, it'd be a squared plus b squared. The a is 0. The b is square root 5. Square root 5 squared is just 5. And this is 5. Same answer, 2 methods. You pick whichever one makes the most sense to you. Questions so far? Okay, I'm going to go one more thing and then we'll stop. So complex numbers and fractions, which is what I was just talking about. To eliminate a complex number in a denominator, we're going to rationalize by multiplying the numerator and the denominator by the complex conjugate. So whatever the conjugate of the bottom is, we're going to multiply both the top and the bottom by it. We'll expand and FOIL out our numerator, and our denominator we can use a shortcut on.
The shortcut being the.
A squared plus b squared, yep.
And what is the conjugate like of? It's the conjugate
Of the denominator, yep. The thing we're trying to get rid of. All right, so divide and express the result in standard form. It's not going to explicitly say get rid of the denominator, right? It's just going to say divide. Or simplify even. All of these can get grouped together and say perform the indicated operation or simplify. You have to know that if the I is in the bottom, technically we're putting a square root in the bottom and we can't leave a square root in the bottom, right? So what would be the conjugate to positive 5i? Negative 5i. So I'm going to multiply both the bottom and the top by negative 5i. My numerator becomes negative 15i. The denominator, negative 25, I squared, negative 25 times negative 1, which is positive 25. And then, as always, you're going to reduce negative 3i over 5. Multiple choice tends to do like negative 3/5 I. It's the same thing. So just realize that's the same thing. WebAssign would take either answer. But like a multiple choice or standardized test usually puts the I next to it. Questions on that one? Okay, last one. My denominator is 5 minus 9i. So what am I going to multiply by?
No. Oh, wait, no.
Close. You just lost the 5. 5 plus 9i. So when it's just a single root, I don't have to worry about the a. But if it's an a and a b, I got to worry about both. So in the numerator, right, I have to FOIL this out. There's no shortcut here. 35 plus 63i plus 30i plus 54i squared. 35 plus 93i, the I squared becomes negative 1, so minus 54. And I get negative 19 plus 93i in my numerator. With me so far? Denominator, I could FOIL out or use my shortcut, a squared plus b squared. The a is 5, the b is 9, put a plus between them, 25 plus 81, 106. If I could reduce it, if the same number goes into all three places, I need to reduce it. Standardized tests may split this up. I actually have no idea what the multiple choice part of this is going to look like on the test. I haven't even gotten there. It may look like that. Just realize that's the same thing.
Mr. Exposer?
Yes, I.
So when you're doing the a squared plus b squared, do you have to take into account the sign in front of b?
In the sign in front of b, no. 1, because you'll always square it. 2, because you'll always make the middle one positive.
Okay.
Yeah.
So even if it was 5 plus 9i, it'd still be 5 squared plus 9 squared?
Correct.
Okay.
Even if it was a negative 5 plus 9i, right? The negative 5 is always going to get squared. It's always going to go back to positive. Questions on where we're at so far? Okay, so tomorrow we will pick up there.